Here's another example of a one proportion z-test. Hit pause and read through it so you're ready to go. We are looking at the true proportion of students, I guess you could say at the school. I'm going to be more specific, at Teon's school that have never smoked. Remember, this opening statement, this is the topic or title that we're interested in. This is what this whole test is over. I'm not putting a claim in there. I'm just looking at the one measurement that I'm taking of my data, and that's a proportion, and you want to describe that proportion. Our hypotheses, it's P equals, and I see a claim that it's 50% that have never smoked. So I automatically write P again and 0.5 again, and I skim the paragraph, and I see nowhere that talks about they suspect it's larger or smaller. It's very vague. So we're just going to test that it's not 0.5. I don't see an alpha, a level of significance, so I'm going to say let alpha equal 0.05. And that number is totally up to you. You could let it equal anything you want. Plan step. Maybe I should start writing smaller. Looks like it was a random sample. N was 150. I plug it into the large counts check. This one's easy to do in our head, right? We use the claimed proportion and 150. So 150 times 0.5 is 75. And so will the complement, right? Sampling distribution is approximately normal. We're talking about a school. We're hoping that there's around 2,000 students at this school, because remember, there is that 10% rule you're not allowed to break. But they don't give us the population, so I'm just going to assume that it checks out with the 10% rule. On the do step, we're going to do a one prop z-test. I need to write down what p hat is when the calculator gives it to me. I know it's 90 over 150. I'm going to find z, which is p hat minus p. And I'll go to the calculator. So maybe on your calculator, try and type it in, see if you get the same results. When I did it, I got 0.6 for p hat. I got a z-score of 2.4495. And by the way, I didn't say this in the last video. You can do this by hand if you want, but AP is A-okay with you doing it all calculator like I'm doing it. This next part is funny to me, because if you're lazy and you just write p-value equals, what is it, 0.0143, I feel like if you're lazy and just write the word p-value equals that, people tend to do better on this type of problem than if they try and do it the textbook way. So the textbook way would be to say z greater than 2.4495, and then you write the p-value. But you got to be careful. This is a two-tailed test. That means that they got the area to the right of 0.6 or to the right of 24495, and they doubled it. So that p-value that the calculator printed out for you has already been doubled. It is 0.0143. If you're worried about getting a 5 on this test, I would say it's crucial that you understand that concept right there. The p-value is 0.0143. It's already been doubled. If you're confused, I'm going to have to erase this in a second. It's because this is our hypothesis. Whoops. 0.5. 0.6 occurred way out here. And it has a tail out there, like a shaded area. The calculator found the area beyond that. That's a z-score of 2.4495. But because it's a two-tailed test, it found the corresponding z-score on the left of 0.4, which happens to be negative 2.4495. So that 0.0143 is the red area. So all that being said, all that I'm trying to communicate is that if you want to write it that textbook proportion way that I wrote right here, you have to write 2 times because it's double the area beyond that z-score. If that's confusing, maybe just write p-value equals 0.0143. That p-value is smaller than alpha. That causes me to reject. So in the conclude step, we can reject HO. Evidence suggests the true proportion of students that have never smoked is not 0.5. All right, see y'all later.